Today we're doing solving exponential and logarithmic equations in section 3.4. Section 3.5 is somewhat related to that. It's like modeling with exponential and logarithmic equations. So it kind of builds off of this, or we use this to help us answer other questions. I'm going to start by just giving you a list of like tips for the two different types of equations you're solving, exponential and logarithmic, and then we'll look at some examples for how that will work. So these are my basic tips for solving exponential equations. I suggest writing a few of these down because if you're working on your homework and you get stuck, then you can go back to this list and say, well, did I try this? Or maybe I can't use this. So I'll give you a little bit of time to jot those down and then we'll talk about them. Okay, so solving exponential equations. The first bullet point I kind of put off by itself. It's probably the one that happens the most often in terms of needing to solve an exponential equation in an application problem, where in the whole equation there's one exponent with a variable in it. So basically you're using reverse PEMDAS. Like get the base raised to its exponent all by itself and then rewrite it as a log. That's what we did in the warm-up, right? Isolate e to the x and then we can rewrite it. Okay. Now these three options basically are options you can use when you have more than one base raised to an exponent. So if you look at your equation and you have multiple exponents with variables in them, you might need to attempt the one-to-one property from section 3.1, where you rewrite them so they have the same base. You might have a trinomial that you could factor, and we'll look at an example like that so you can see what that looks like. And then this last one, I'm going to put a little star by it. Taking the natural logs of both sides is something you would use when you can't rewrite with the same base. So if you were trying to use a one-to-one property, but there was no way to rewrite the two numbers with the same base, then you can use this method. And so probably in Algebra 2, you did the first two bullet points, so I don't spend a lot of time today talking about those. And really factoring and taking natural log of both sides, that would be more of like, I'm in pre-calculus now. I know more than I did in Algebra 2. I hope. Okay, the next set of tips that I'm going to give you are for logarithms. and then we'll get into looking at some examples. Get used to it. Well, I feel like when you're giggling. Okay, so that top bullet point is, again, probably the most common that actually happens when you're solving exponential equations is you're going to have one log in the equation, and so you just isolate the log, get the log, its base, and whatever you're taking the log of all by itself, and then rewrite it in exponential form. You guys have actually already been doing the first bullet point back in section 3.2 when I would ask you to solve for x-intercepts. Plug 0 in for y, you'd move plus or minus, multiply, divide to the other side, and then you would rewrite it in exponential form. Okay, so we kind of already know how to do that. Now, there could be times, again, where you have more than one log. And if you have more than one log, you might be able to condense logs. So remember, like 2 logs with the same base that are being added can be condensed into 1 log with multiplication. 2 logs with the same base that are being subtracted could be condensed into 1 log with division. You might use the one-to-one property if you just have like log base 5 of something equals log base 5 of something else, then the two somethings have to be equal to each other, so you can drop your logs and set them equal. Now, there is a little note at the bottom of this screen, so make sure that you made a note to yourself, and I would maybe star circle or highlight this, that for a log equation, it is your responsibility to check for extraneous solutions. Now, I don't need to see that check necessarily, but it is something that you should be thinking about. So if there's a solution that is extraneous, you should tell me that. Just to review really quickly, I don't think we've talked about it so far this year, but the word extraneous just means false. So it doesn't necessarily mean incorrect. Like, you did your solving right. That is the answer you should get. But when you plug that answer into the equation, it doesn't work. So it's a false solution. And those solutions are going to be created in log equations. If you plug your number back in and you try to take the log of 0 or take the log of a negative number. Think about the basic log functions in their graphs. Their domain is restricted by a vertical asymptote at x equals 0. So you can't put anything, or you can't take logs of negatives or 0. So if your solution would ask you to do that, then you would mark that solution extraneous. Okay, let's look at some examples. E to the 2x minus 3e to the x plus 2 equals 0. So I notice that this is an exponential equation. Variable is in the exponent. I see that I have more than one base raised to a variable exponent. I have e to the 2x. I also have e to the x. So I'm thinking about those options that I have in the tips. I could solve by one-to-one property or maybe by factoring. Now in terms of one-to-one property, I would need to be able to have these two base raised to exponents that equal to each other with nothing else there. But if I were to like add the 3e to the x the other side, there'd still be this plus 2 hanging out there, which I'm never going to be able to get rid of. I'd subtract it to the other side and then I got minus 2 hanging out. So one-to-one property is out, right? One-to-one property I got over here on the sideboard. It has to be a base raised to an exponent equals a base raised to an exponent. Okay, so this is not going to work for the plus 2. So then I'm left with trying to factor it. Now, one thing you can do to kind of help you with factoring is probably the troubling part is the e's, right? So I see that this is e to the 2x and this is e to the 1x. And I'm just going to like think about what that might look like in an old polynomial that I'm really comfortable with factoring. That e to the 2x is like my squared term. So that's 1x squared. And then I have minus 3e to the x. That's like my x term. Minus 3x. And then of course I got plus 2 equals 0. Can you factor x squared minus 3x plus 2? Yeah, what would be your two factors? Negative 2, negative 1, x minus 2, x minus 1. Okay. So if I can factor this one, x minus 2, x minus 1, then over here, I know that I have to have a minus 2 and a minus 1. That's going to get me this negative 3 for my middle term. What are the first terms? E to the x. E to the x minus 2, e to the x minus 1. Now let's think about that. These things are the same as the middle term, right? So the middle term was just negative 3 e to the x, so they should match that so that I will get negative e to the x, negative 2 e to the x, which is negative 3 e to the x. And if you think about foiling that out on your first terms, e to the x times e to the x, what would you do with your exponents? Add them. X plus x is 2x. Okay, so that works out. Okay. Now, you factored it. How do you solve? Set your factors equal to 0. So now set each factor equal to 0 and solve for x. E to the x minus 2 equals 0. E to the x minus 1 equals 0. I'm going to have to isolate my base raised to the exponent. So I have e to the x equals 2. I can rewrite that. That's the natural log of 2 equals x. I can type that into my calculator. And then I'll do the same thing over here. E to the x equals 1. That's the natural log of 1 equals x, which I know that has to be 0. Anything to the 0 equals 1. Can someone give me natural log 2? 6929, so I'm going to say 0.693. I usually go to the thousand. So that's 3 numbers after the decimal. Yep, and this one, don't you normally have 2 answers when you factor like a quadratic? Yeah, each factor produces its own solution. There could be multiple that work. Now, this was exponential, so I don't have to worry about any kind of extraneous solutions. Those answers must both work when I plug them in. Okay. Let's do one more exponential one. 3 to the x equals 7 to the x minus 1. Now, this might be one where I say, okay, I have multiple base raised to exponents. So I'm thinking about my 2 options, factoring or one-to-one property. And I might think, well, it's not going to factor, so maybe I'll do my one-to-one property. But this is tough because is there any way to rewrite 3 so that it has a base of 7? there any way to rewrite 7 so that it has a base of 3? Well, they really have like no common base factors, and so that you can't rewrite them. So this is that third option that I gave you that I put 2 stars next to when you can't use 1-to-1, when you can't rewrite it with the same base. So we have a workaround, mathematicians, for this. Take the natural log of both sides. Now we say take the natural log of both sides. It could be the log of it. It could be any log of both sides, but it would have to be the same base. You've got to do the same thing to both sides. So I say do the natural log. Okay, so I'm going to take the natural log of 3 to the x. That's equal to the natural log of 7 to the x minus 1. Alright, then in the tips it said take the natural log of both sides and use your properties of exponents. So thinking about your properties of logs. Thinking about your property of logs, what can you do if you have an exponent on the back of 3? Multiply it in front, right? Bring it down. So this is really x times the natural log of 3 equals x minus 1 times the natural log of 7. Now, this equation looks a lot worse than it actually is because it has the ln everywhere, the natural log. So, do you agree with me that if we were to type in natural log of 3 and type in natural log of 7, like those are just decimal numbers, the calculator would spit out to us, whatever that may be. So, I'm off to the side going to make an easier equation for you. I'm going to take out the natural logs. This is not the same thing, but it's like this. What if instead of x times natural log 3, it was just 3x? And what if instead of x minus 1 times the natural log of 7, it was just 7 times x minus 1? Does that equation look like something you could solve? Yeah, what would you guys do to that equation? You would distribute the 7. 3x equals 7x minus 7. So we would distribute. What else would you do to that equation? You would subtract the 7x. So I'm going to say get x on one side. So that would be 3x minus 7x equals negative 7. And then you have like negative 4x, right, equals negative 7, and you can divide. So keep solving. So let's do the same things we would do, but with natural log 7 and natural log 3. So the first thing you would have done was distribute. Okay, I'm going to distribute. The natural log of 7 times x, and the natural log of 7 times negative 1. So I'm going to write that as x natural log 7 minus natural log 7. To me, that's the same thing as what we have on the side, 7x minus 7. But we're just using a different number, natural log 7. So we distributed. If you need to make a little note in your notebook about what you're doing for these steps, write down that you just distributed. Now what do you want to do to solve for x? After you distribute? Subtract the 7x, or get x's on the same side. In this case, we're going to subtract x natural log 7. So this is going to be x natural log 3 minus x natural log 7 equals negative natural log 7. Okay, so like that could be, like this could be a weird moment for us because when you move that x to the other side, since one is natural log 3 and one is natural log 7, they're not really like terms. You can't like subtract them right away. But if you think about it like this, both terms have x, so I could take out an x, and then I'm left with natural log 3 minus natural log 7, which is essentially the same thing as subtracting them, right? If you're going to subtract those two numbers, x natural log 3 minus x natural log 7, you're taking natural log 3 minus natural log 7, and it's an x term. You're subtracting their coefficients. So that's equal to negative natural log 7. So if you need to mark a note to yourself, what did you do right there? You factored out x. And now can you solve for your x variable? If it's x times a bunch of stuff, what do? Yeah, you divide. You do the inverse operation of multiplication. Remember, all this stuff right here is just a number. It's a decimal minus another decimal, whatever the calculator will give you for natural log 7 or natural log 3 and natural log 7. So I could divide both sides by natural log 3 minus natural log 7. And so my answer is whatever natural log 7 over natural log 3 minus natural log 7 is. Now, when you type this in your calculator, if you leave it like this, because you're subtracting in the denominator, you'll need a group of parentheses. Some of you may see that as a condensing. So they're both natural logs. They're being subtracted. I could write it as the natural log of 3 divided by 7. 3 sevenths. Excellent. Remember, the negative 1 goes in the bottom. Those two answers should give me the same number. So why don't you pull out your calculator and make sure you can type this into your calculators correctly. So I'm going to do the one with the subtraction first, just to kind of model how I would do that in my calculator. So I'm going to do negative natural log 7. Now, when my calculator brings up that parenthesis for a log, I have to close it. And then I'm going to do divided by, but because I have stuff happening in the denominator, that stuff needs to happen first. I need to put a parenthesis around my denominator. So I'm going to do parenthesis for the denominator. This is natural log 3, close my parenthesis for the log, minus natural log 7, close my parenthesis for the log, and I would do a double close for my denominator, although it doesn't really matter if you close your denominator or not. And then hit enter, so I get 2.297. And if I do this other version where we saw it as condensed, I kind of like it because I don't have to worry about those parentheses. Negative natural log 7, close my parentheses for the log, and then divide by the natural log of 3 divided by 7. Oh, same answer. So x is about 2.297? So that is kind of like a weird moment to be in, but again, this is one of those problems that I would say really makes you a pre-calculus student and not an Algebra 2 student. So you want to focus on the things like, what are the things that I really have to reach for in terms of learning? Like that doesn't come natural to me because I didn't know it before. So make sure you practice these types of problems. Maybe redo this problem on a separate sheet of paper for homework tonight. And then you can always think back to like, what would you do if they were just nice numbers? The rules don't change. The solving is still the same. It just looks funny because it's natural logs. Questions, concerns about that problem? Okay, so we're going to move on to logs. This one will be pretty quick. Natural log 3x equals 4. When I survey this equation, I only see one log. So that means I can isolate the log and then rewrite it. Is there anything I can move from the side that has the log? No, don't be tempted to divide by 3 because that's trapped inside the logarithm, right? So you must rewrite it right now. What is the base of this log? E, so that's e to the 4th equals 3x. And then to solve for x, just divide by 3. So in your calculator, you can type that in. Now you want to make sure to grab the e, so you have to do second ln to to get your e, raise it to the fourth, divide by 3. I think I get like 18.2. Okay, now remember, there's one important thing that you're responsible for when you solve log equations. In the end, you need to make sure that that answer actually works. So what I'm thinking in my head, and you don't always have to show this, I'm just showing you what I'm thinking about right now. I'm thinking about on the side where there are logs, if I plug that number that I got, 3 times 18.2, that's the natural log of a positive number, so it's good. It's not extraneous. If I had said that that was going to be the natural log of 0, or that that was going to be the natural log of a negative number, I would cross out that answer and say extraneous. So I'm not even really checking for accuracy, right? I'm not actually evaluating it to make sure I did it right. You could if you wanted to. I'm just making sure that I'm not taking logs of 0 or negative numbers. And that could be like a 5-second check, and then I move on to the next one. Okay, so let's do some more interesting logarithmic equations. Suppose we have log base 9 of x minus log base 9 of x plus 1, and it's equal to 1/2. Okay, when I look at this problem, I notice it's a little bit different than the last one because there's multiple logs. So when I have more than one log, I can try to use one-to-one property. If they were both log base 9 and I could set them equal to each other, I could just drop the log and say the two things were equal and taking the log of. But just like that one where we had a factor, that 1/2 is trouble for us, right? It's not going to let us use one-to-one. So then our other option when we have more than one log is to condense. Okay. So let's condense the two logs. They have the same base. So they can be rewritten as log base 9 of, because they're being subtracted, they're going to condense into division, x over x plus 1. Okay. That's equal to 1/2. Well, now I've got it to one log, so that's good. That means I can rewrite it in exponential form. So the base to the exponent is going to be 9. The exponent is 1/2, the answer to the logarithm. And then that equals x over x plus 1. Now, what are you really doing when you do 9 to the 1/2? You're square rooting. So think about algebraically, if you square root to solve, you have to add a plus or minus here. Now you wouldn't always have to put the plus or minus unless you're taking a root, a fraction exponent, okay, or an even root, I should say. So we're going to put plus or minus 3 equals x over x plus 1. So there's really two equations there, which leads me to believe I might have two solutions. How will you solve for x if you have a statement like x over x plus 1? Any ideas? Noah? Yeah, you really can't solve for x when it's in the denominator, so I will multiply both sides by x plus 1. That's going to give us an equation where we have x's on both sides, but we're able to solve those. So then cancel those out. Now this is being multiplied by positive or negative 3, so I'm now going to separate it into two equations. One of my equations is positive 3 times x plus 1 equals x. And the other equation is negative 3 times x plus 1 equals x. Those are some pretty basic equations that you could solve, no problem. couple of steps there. Distribute 3x plus 3 equals x. I would subtract my 3x so that I get 3 equals negative 2x and x equals negative 3 halves. And then on the other one, I'll have negative 3x minus 3 equals x. This time I'm going to add 3, so negative 3 equals 4x, and x equals negative 3/4. Bless you. Because that's a log equation, I should check my answer, right, for extraneous solutions. So we've got negative 3 halves and negative 3/4, and when I look back up at the original problem, first log is trouble for both, right? Can I do log base 9 of a negative number? No. So both extraneous, which means you have no solution. There is no number for x that you can put into this left side and make it equal 1/2. Okay, so there's no solution. So I would go down here, I cross them out, and then I write extraneous. And my final answer would be no solution. Another abbreviation there for you. Okay? So sometimes maybe you'll have 2 answers, sometimes maybe you'll have 1 answer, sometimes you have no answers. It really just depends on what happens with the equations. Okay, now we're going to look at one more. And in terms of logs, I would say, like in the exponential equations, the one where you have to take the natural log of both sides, that's probably the worst of the worst. In terms of log solving, this example would be what I would call the worst of the worst. Like, this is bad. Last one was long, but easy to solve when I got down to it. This one maybe requires a little bit more work. Not even work. Okay, natural log x plus natural log x plus 2 equals 1. We're running into the same issue, right? One-to-one property isn't going to work because there's that 1 on the other side. So I really want to condense my logs. This time my 2 logs will condense into multiplication, x times x plus 2. So, that's the natural log of, I'm going to distribute x squared plus 2x equals 1. Well, I've isolated the log, so I can rewrite it. What's the base? E. So this is going to be e to the first equals x squared plus 2x. And now I've got to rely on my knowledge about quadratic equations. What are my options for solving quadratic equations that have x squared and x in them? I could try to factor it. So in order to factor, one side has to be set equal to 0. So that means I'm going to have to subtract my e. So that's 0 equals x squared plus 2x minus e. And I'm not going to be able to factor with e, because that's irrational. So what do you do when you can't factor? Your quadratic formula. So I'm going to mark in my notes here. A is equal to 1, B is equal to 2, and C is equal to negative 2. I'm going to say, like, what we want to concentrate on right now is, of course, plugging into the quadratic formula, but more importantly, like, putting that into our calculators accurately. So if you can kind of be with me in practicing, then we can kind of troubleshoot your calculators in case we have any issues. So before I go to my calculator, I'm going to write out some things because I like to simplify it a little bit if I can. This would be x equals the opposite of b plus or minus the square root of b squared minus 4ac, which happens to be e. Oh, negative e. Sorry, negative e, that makes a difference. Divided by 2 times 1. if I'm going to use my calculator for the quadratic formula, I'll try to simplify what's underneath the radical first. So 2 squared is 4, and then negative 4 times 1 times negative e is now plus 4e. And if you need to mark it as 4e to the first, because you have to put an exponent with e in the calculator. Okay. Now, you can't add 4 plus 4e because they're not like terms. So I'm just going to leave it like that and go to my calculator. If I want to do all of this in my calculator at once, I have to be really careful with my numerator because I have things that are being added or subtracted, right? So in the calculator, that means I need a group of parentheses. Okay, so I'm going to start my calculator, parentheses. And then I'm going to do negative 2 plus, there's no plus or minus button, so you have to do them separately. Then I'm going to pull my square root. Now, my calculator has like all the stuff under the square root, so I can just type 4 plus 4e. And I'm going to give it an exponent of 4e to the first, and I can get out of the square root by hitting to the right and then close my parentheses. If you have a calculator that when you type it in, it looks like negative 2 plus square root parenthesis, then you have to do 4 plus 4e to the first. You got to close your parenthesis for e and close your parenthesis for the radical, and then you got to close your parenthesis for the numerator. So if you have that older version, you got extra parentheses. You opened it for the numerator, you opened it for the square root, you opened it for e, so you close it 3 times right there. Okay. If you have the Casio, does anybody have the Casio in here? The white one? Okay, the Casio needs parentheses if you have it. And then I could just do divided by 2. Because 2 times 1 is 2. If I didn't multiply that in advance, if I wrote 2 times 2 or something like that in there, I would need parentheses if I'm not going to put 4 in by myself. Okay. So I get one answer, 0.928. Now, if you have the newer versions, you can just click up and it will take you back in there and you can change your negative. You can change your plus to a minus. If you have the older versions, the 83 or the 84 silver, note this. If I do second, enter, it brings up what I just did. So then I can scroll over to that plus and change it to a minus. So if you have the older version, it's second, enter. It'll go up to the entry above. And you can keep clicking second, enter to see other things you've done. Let me know if you're having trouble with your calculators. Let me write these up and then I'll put that back up. If you're not getting these 2 answers, let me know. I want to look at your calculator and see what you're doing. You don't get 0.928 and negative 2.928. Anybody having trouble? Oh, you need batteries. So yours has the battery. And this, like, it will eventually tell you, like, this is the batteries. Put that on your list. Anybody having trouble with the calculator? Okay, you do have a homework assignment. It's on that gold sheet. If you're a junior, you probably want to be working on it a little bit each night so you can have it done Thursday. If you're a sophomore or a senior, you're going to have study hall tomorrow in class. If you want to work on your assignment then, that'll be acceptable. All my juniors are going to be doing that.